Hello everyone, in this video we're going to discuss a problem, Ilya and the Tree from some past Codeforces round. The problem is based on graphs, especially trees and number theory. What the problem is all about that we are given a tree rooted at vertex 1 and there is an integer number written on each vertex of the tree. The number written on the vertex I is AI. And also, what we have to find out for each vertex x the greatest common divisors of all the numbers written on the vertices on the path from the root to the x, the vertex itself. And also, what we can do, we can change the number in any arbitrary vertex to 0. That is, we can drop one vertex, or we can leave all the vertices unchanged, and then we want to know the maximum possible GCD of the remaining numbers. And for each vertex, we have to note the answer must be considered independently. So how we're going to solve this problem? Let us try to understand the problem first with the help of example. So here, let us say we are taking the example of test case second, where we are given three vertices, and here the number on each vertices are 6, 2, and 3, and 1 and 2 are connected, and 1 and 3 are connected. As 1 and 2 are connected, 1 and 3 are connected, and thus numbers written on this vertex are 6, 2, and 3. So if we see the vertex 1, so what are the if we see the vertex 1, so what are the vertices that are coming in the path? So the vertices which are coming in the path from the for the vertex 1, from the root to the vertex is only one, which is this vertex. And what is the number written on that vertex? It is 6. So the GCD will be 6, or you can also drop one number. If you drop 6, you will get the answer as 0, but we want to answer the maximize our answer, so we will take 6 as the answer for this vertex 1. That is, for our answer or result array, the answer for the vertex root will always be the number written on the root. And now if we consider vertex 2, the number of vertices, numbers on the vertices which are on the path from the root to the vertex are 6 and 2. So if we take the GCD of 6 and 2, it is 2. But we have one privilege that we can drop at most one vertex. So we will drop the vertex 2. So then we will get the GCD as 6. Similarly for vertex 3, what are the number of numbers on the path from the vertex of the root to the vertex? It is 6 and 3. We can drop 3 and then we'll get the GCD as 6, and so our result array will be 6 comma 6 comma 6. So let us try to understand this more with the help of another example. So I have drawn one more tree where we have a bunch of vertices and the numbers also written on the vertices. So first of all, we should understand, like if we see the vertex root, we should not drop any number. We should not drop the number on the vertex of the root. So we should keep it as such. So the answers for the root is always the number on the root. That is, if we have the result array, then the number on the root will be in the result array. So if we see vertex 2, so what are the vertices coming for the vertex 2 on the path numbers? These are 5 and 7. So if we take the GCD 5 and 7, it is 1, but we can drop one number using our privilege, and so we can drop 5, so we'll get the GCD as 7. Similarly, if we see for vertex 3, we will drop again 5, we will get the GCD as 8. Now if we see the vertex 4, the GCD of 5, 7 and 9 is 1. So we can drop at most one vertex. If we drop any vertex, you can see the result will not change. So the GCD will still be 1. And if we see the vertex 5, it is very interesting because you can drop, here the GCD of 5, 7 and 5 is 1, but you have the privilege of dropping one vertex. So we will drop the vertex 7. So our GCD will be 5. So on and on and on we can do the like this manually, but first of all we should understand this fact from these 5 vertices that there are two cases. In one case we will drop the value on the root, in other case we will not drop the value on the root, we will drop some other value. And even if we do not drop any other value, we can say that we have not dropped the value at the root. So there are two possible cases, whether we will include the root or we will not include the root. So include, and this is exclude, and this include and exclude I mean root, value at the root. So what we can do, we can initially uh, assume that we are dropping the value at the root, and for each vertex the GCD will be the value of the GCD till the parent and the value of the vertex number itself. So for GCD, if we drop the root, will be GCD of the parent, comma, the number itself, that is AI. So for vertex I, initially the value of GCD will be GCD of the parent and the GCD of and the number itself. So then what we can do further, if now let us say if it takes some path, let us say this 9 is we consider this vertex 9. So what are the numbers coming on the path? 5, 7, 9 and 1. 5, 7, 9 and 1. Initially we will consider that we have not taken the root, so our root is 0. So then what we can do from here, we should first of all know that if we are not taking the root, then it is the answer is the GCD of all the numbers which we have written here already. But let us say this is not a maximum answer, this is not the optimal answer. The optimal answer will come if we include the value of the root. So if we include the value of the root, if we include the value of root, then it means the answer will be one of the divisors of the value at the root. So if we construct the divisor array, so here in this case of 5, the divisor array is 1 and 5. So if we construct the divisor array and we will initialize this array, initialize another array which we call as count array, which will denote that how many vertices we have dropped till that point. So in the initially we have not dropped any vertex, so we will initialize the count array to be 0 and 0. But as we go down the route to the vertex, if we find that we have dropped at least one value, at max one value, and then there is some number which is divisible by all the numbers except one number, like for example in this case of 5, 7 and 10, like just a minute, 5, 7 and 10. If we drop this number 7, our GCD is coming as 5. So it means that we have to we can take the GCD as the maximum of the or our GCD which is initially, which is this value, or the divisor value, which is whichever with the maximum, which will be our answer. Because here initially 0, 7 and 5, this 10, the GCD is 1, but if we drop this 7, the GCD will become 5. So 1 is less than 5, so the answer will be 5. So, and what we will gonna do, we will gonna propagate this information of the count array, that how many number of vertices we have dropped to get any value of the divisor, of the divisor array. And if that value turn out to be -1 or more than -1, -1 will denote that we have dropped one value, and 0 will denote we have not dropped any value, and -2 will denote that we have dropped two values. So then in this way, if we have dropped only one value, then it will be, we can take this as a eligible candidate for the answer. So if we have dropped only one value or no value, we can take this value to be eligible member to be checked against or matched against this original value of the GCD, and if it turns out to be more, as in this case, we will initialize this as our answer. So let us now look at the code to understand it a little bit better. So here I will first of all initialize the input, and I will then connect those edges, and then this is my result array, this is my divisor array, this is the normal divisible divisors calculation as we do. If the number is divisible, we will push to the divisor array, and then further we will have this count array, and we will have initialize the size of the count array to be the size of the divisor, and the value of the count array at all the positions is 0. Then we will do the DFS traversal, and the DFS traversal we will do at the vertex root vertex, which is 0, and it's we will initialize its parent as -1, and we will initialize the value of 0 as the GCD uh, of the root. And then what we will gonna do, if our the number is not divisible by the any divisor, we will drop the value of the count corresponding to that divisor. And if we find that we have dropped only up to one value, then we will consider this as a potential candidate for the answer. That is, it will be equal to the this corresponding to the maximum of this and the divisor of this. So then what we're gonna do, we will after that we will traverse those vertices which are not visited, and after the recursion will broke out, what we will gonna do, when we will gonna push top, then we will increase those the value of the count array in such a way that those values are considered which are not divisible by I. As we have dropped here, we will increase here so that it will not affect the result. That is, if I try to explain, and in the final we will just output the result. That is, if I explain this through example of here, then just a minute, I should clear some here. Yeah, and this is 5 is also not there. Yeah, so yeah, let us say here initially we have the value of the count array as 0 and 0. Now we will check whether this number 5 is divisible by this 1. Since it is divisible, we will not drop the value of count, and we will initialize, because GCD initially we have taken for corresponding to the root vertex as 0, but now this 1 is more than 0, so we will take 1 as our GCD. Then 5 is also divisible by 5, so this 5 will be considered as another candidate for the answer corresponding to this vertex root vertex. So we will we will then see that whether 5 is maximum than 1 or not. If it is since it is maximum, so the answer for this vertex will be 5. So when we come to the vertex 2, here we have the value as 7. So if we check the divisibility of 7 with 1, it is divisible. So it will not change. We have not to drop for it to be considered as for 1 to be considered as the answer for this 7, and it will not drop any because 1 is the divisor of all the numbers. But 7 is not divisible by 5. So we have to reduce this 7 to get 5 as our answer. That is, if we consider 5 and 7, if we want our answer to be 5, we have to drop this 7. But initially our answer is the GCD of 0 and 7, which is 7. So 7 is not less than 5. So our answer for corresponding to this vertex will be 7. Similarly for this vertex, but this will come later on. First of all, we will go to the more depth because it is a depth first traversal. So we'll here at point 9, we will say 9 is divisible by 1, so we will not drop this value of the count corresponding to this divisor 1, but 9 is not divisible by 5, so we have to drop 2. But if if 5 is to be considered as a potential answer, so we cannot drop more than 1. So here we have dropped 2. It means like we have to drop 9 and 7 to get 5, but it cannot happen. So it means, since this is not a potential answer, but this can be a potential answer corresponding to this divisor, which is 1. And if we see the GCD of 0, 7 and 9, it is already 1. So the answer corresponding to this will be 1. Further, we will go down further. So it 1 is again divisible by 9, but 5 is 9 9 is this 5 is not divisible by 9, so this will be 0 minus 3. So only 1 can be considered as a potential candidate, and already if we see 0, 7, 9 and 1, let us say I will mark it at 0 because I am saying this 0 again and again, you will just get confused. So 0, 7, 9 and 1, this it is already 1. So when we come, then after that there is no vertex which is visited, so we will go back to the parent, and then in the process of doing so, we will restore the value of the count array. That is, if this value is not divisible, we will add 1 as we have done here to restore the value of the count array. Then we will go further up. We will restore the value of the counter is to be 0 comma minus 1. But when we come at this point 5, now 0 is now initial GCD is GCD of 0, 7 and 10, which is 0, which is 1. Now since 10 is divisible by 1, so it is 0, but and at the same time 10 is also divisible by 5, so we will not drop minus 1 to be further to minus 2. So now since minus 1 we have dropped only one number for this divisor, it can also be an eligible candidate for the answer. So 5 can also be a candidate for answer, and in fact 5 is greater than the GCD of 0, 7 and 10, which is 1. So we will then output the answer for corresponding to 5 to be 5. In this way we will go on further, and then the recursion will break out. We will go here, then we'll go here, and in this way we will just traverse the graph and also output the result. So I hope you understand some part of the example and the proof, and hope you I will upload more videos on graph theory and dynamic programming in future, very soon, every day maybe. So hope you like this one. See you next time. Have a great time.